December 12, 2023, a construction crane at a multi-level car park project near Rawang collapsed onto the KTM railway tracks. This wasn't just a minor delay, it is a disrupted over 30,000 passengers and caused roughly 2.4 million ringgit Malaysia in losses. The fallen booms damaged the 25 kilovolt overhead electrification system, creating a high-risk environment for both workers and the public. While the project was managed by a private contractor, it was situated on slope adjacent to active critical public infrastructure. Our video today was to analyze why this situation occurred and how it intersects with the laws governing our profession.
To analyze the failure, we must establish a technical baseline. It is important to note that since official site logs are restricted and unavailable, our team used engineering assumptions to model a worst-case scenario in this situation. By assuming a cohesive soil type with a cohesion 40 kN per meter square and a factor of safety about 3.0, we calculated an allowable bearing capacity of 104.8 kN per meter square. In contrast, the contact pressure of the crane, of 100-ton crawler crane, was approximately about 200 kN per meter square. And as the difference, it is resulted to 95.2 kN per meter square. That is deficit proves that the collapse was a mathematical certainty, and the crane sank because of the ground simply couldn't carry the load enough. A failure likely caused by relying on generic soil values instead of site-specific borehole data. This technical failure directly triggers the Registration of Engineers Act 1967 under Section 15. The failure to verify soil strength at the crane's specific footprint constitutes the gross negligence. Furthermore, Section 7(1) requires that only a professional engineer with a practicing certificate PEPC can sign off on such works. If a PEPC endorses a platform where the load exceeded the capacity, they endorse a guaranteed totally failure. The statutory consequences are severe, from disciplinary action and license revocation to potential criminal charges under the Act.
Beyond the law, there is the BM Code of Professional Conduct, Regulation 33, states that an engineer's primary duty is to protect public safety. By allowing a live lift next to active track without adequate protection, the engineer failed to prioritize the safety of thousands of commuters. We identified several ethical failures, which is inadequate site investigation, poor risk assessment, and the potential pressure to prioritize project timeline over safety protocols. All in all, ethical is the main part to become an engineer, even though you're in any other industry.
In conclusion, the Rawang crane's collapse was entirely avoidable. It was the result of cascading professional failures, from the lack of empirical soil data to the disregard for safety buffer zone. To rebuild the public confidence, we must enforce strict competency-based endorsement. Engineering isn't about just moving loads. It's about the integrity of the math behind the movement. And the law will hold who ignore the math accountable. That's all from us. Thank you.